A very warm good afternoon to all of you. I'm Sakshi, welcoming you all on behalf of eMobility Plus and First View Group to our webinar on forging links in India's EV battery supply and technology chain. Before we dive into the presentation, let me give you a quick overview of what to expect from today's webinar. As we know, in the dynamic landscape of EV development, India stands at the forefront of innovation and progress. Central to this evolution is the intricate network comprising the EV battery supply and technology chain. As the automotive industry transitions towards sustainability, the role of efficient, reliable, and scalable battery technology becomes increasingly important. The webinar today aims to unravel the complexities and challenges within India's EV battery ecosystem while highlighting the collaborative efforts and groundbreaking advancements propelling it towards a greener, more sustainable future. Our webinar today will explore the pivotal role of partnerships, technological advancements, and strategic initiatives in forging robust links with India's EV battery supply and technology chain. Now, allow me to quickly take you through today's agenda. Our webinar is divided into two sessions. The first session will feature insightful knowledge presentation. In the second session, we shall engage in a dynamic panel discussion. Post that, we'll have a Q&A session where you can ask your questions to our panel of experts here on the screen. Here, I would like to make a small request. Attendees can post in their questions in the Q&A box, and our speakers here will answer those once we conclude with the panel discussion session. Before we proceed, I would also like to take this opportunity to invite you all to our upcoming event, the EV Manufacturing Show 2024, which is going to take place on 24th of May at Bangalore. Join us and stay ahead in the dynamic world of electric mobility. My team here will play a short video now.
Electric vehicles are changing the way we move. There is a sustainability in motion. It's silent but powerful. The future of transportation is here, and it's electric. Gear up for the biggest EV manufacturing event of the year. EV Manufacturing Show 2024, powered by eMobility Plus.
Thank you, team, for playing that video. Now, without any further ado, we shall initiate our webinar for today with the knowledge presentation by one of our most esteemed speakers, Mr. Randeep Singh, who's the CEO at 4C Advisors Private Limited. Welcome, Mr. Randeep, to the screen. Over to you.
Thank you, Sakshi. I'll start the presentation, right? Or it will be displayed from your side. Should I display?
Yes, please start sharing. You will see option present to audience right next to the mic.
Is it visible?
Yes, it is visible. Please go ahead.
Perfect. Thank you very much. As I understand, I have 10 minutes for this presentation, and in fact, it's a very, very important discussion. I was just listening 5 minutes back to the upcoming panelists who are going to discuss. They are from the all streams, right? From the recycling, from battery swapping, battery manufacturing, and all. In fact, it's a very, very good mix if when we are talking about the link to this entire EV value chain. So how it's a very, very short presentation, a sort of guide how to navigate the treacherous train of EV battery ecosystem. Now, in terms of the challenges which India's EV battery supply chain has, everything starts from this, the base, which is the material. This was the report by the Niti Aayog itself that how the demand of critical minerals and the raw materials for lithium-ion battery value chain will be by 2030. So, in fact, everything starts from the cathode active material around 193. This everything is for 100 gigawatt hour per annum by 2030. If we consider the current scenario, in fact, the 60% LFP may become around 65 to 70% of LFP. This requires around 193 tons per annum of cathode active material, which is lithium bicarbonate, is what is being considered here. Around 98,000 tons per annum of nickel sulfate. So, and if we go to the spodumene concentrate, so when we talk about the lithium, it comes out from the different raw materials. It can be the brine, it can be the lepidolite, it can be the spodumene. That is where the spodumene concentrate comes. Around 56,000 tons of per annum would be required. This is, and if we convert it into the spot price, which was of April 2023, this amounts to around 1,695 million US dollars. It's a lot of amount. So that means that entire value chain right from the beginning itself requires a lot of money for it to be established. In fact, this number, if we talk about in the current scenario, the value may not have gone up, but the requirement has gone up already. Now, next comes the recycling part, because finally recycling is also in one way very closely associated with the raw material, which is the critical minerals, which goes directly into this. So we have the lithium cobalt oxide, lithium iron phosphate, lithium manganese oxide, NCA chemistry, wherein the cobalt and aluminum dominates, and the NCM chemistry. In this, if we say, and of course, energy density wise, we know already NCA is the highest, but the safety perspective within all these, LFP makes the biggest dent. That's why the LFP is going to dominate in the future. However, when we talk about the recycling perspective, LFP is the one wherein the maximum number of problems arises. You know, to do the recycling of LFP viably. In fact, from Lyco, I see the CEO of Lyco is here. Gaurav, I think he would be in a position to tell what all practical difficulties people will face when we go for the LFP recycling. However, if we talk about the adoption, one good sign which has come up is people are now shifting to LFP, but recyclers also need to do a lot of work, because down the line, 5 years down the line, when these batteries will be in the market for the recycling, and we'll be looking at the critical minerals reusability, this is the place where a lot of attention is required. Now, in terms of what are the challenges in this in this link in the supply chain, so there are supply chain disruptions, technological hurdles, regulatory compliance challenges, market volatility, and the collaboration dilemmas. If we talk about the supply chain disruptions, it starts right from the beginning, which is the raw material side. In fact, let me go to some more slides. This is where these Now, the falling prices may look good for the market, but how about it for the business, for the recyclers, for the camp producers, even for the companies who are doing the processing of the raw materials and who has bought these mines for 6 to 7 to 8 years. In fact, the mines contracts run perpetual, and those has been bought at a very high price. Definitely, it won't be feasible for them to do the processing at this particular cost. Of course, at the end, when the market dominates, the prices are being dominated from them. However, it will make dent in the overall scenario, and that's why we have seen recently, in fact, in the last 2 months itself, the demand it has slowed down. The reason is very very simple, because all the economics works, right? If the person who has paid a lot of money, right, from the raw material for the processing, for the camp production, for the validation of their material, for the battery production, but they are not getting the enough value of this, it is going to impact a lot, right? And the fall is actually exponentially down, and this is going to impact a lot. Entire supply chain is going to be impacted right from here. But optimism remains that at the 20.5% AGR, still the market is going to grow. That is what the market optimism is. But if you see the realism on the right hand side of graph, the realism is this, right? So whatever is the perception and whatever is the reality, there is a great mismatch. The mismatch is quite high. Similar thing comes here. What market is thinking, what is the market optimism in terms of the supply chain, and what is the exact the data in terms of the production. So if we see from even from the 2030 itself, everything is going to be very very different. The realism is going to be far less than the optimism. And these are the projections which has been validated by many sources. There is another component which is very very crucial in the entire supply chain, is the graphite part. Why? Because we talk about almost the cathode and the anode, but anode is always left behind. The reason is very simple, that almost 92 to 93% of the graphitization right now which goes into the battery is controlled by the one country itself, and not many countries are thinking about the localizing it. Fortunately, in India there are a few players who are actually doing it. So it starts from the both the sides. We need to have the natural graphite as well as the synthetic graphite. This is the place where the China dominates very very deeply, the synthetic graphite one. This comes from the fossil fuels, and this is the natural graphite. This is available in India. However, the synthetic graphite is the one wherein we also right now strive. And when we talk about the grade 1 which goes directly into the cells, that is the place where it takes a lot of time. Even the validation takes almost 2 to 3 years. After that, it is you are set for the 6 7 years, but then 2 to 3 years time which has been lost. During that time, the prices goes down very fast. Now we are talking about the graphite silicon anode. This is the further breakdown in the at the cost level, where the cost comes, how the direct materials contribute to this graphite cost. Now, this is very important, how these chemistries are going to move and which is going to dominate in the long term. So, if we see on the very left, the NMC 811. In fact, today morning I had a call with the CATL, and they were saying at the cell level, they have already announced the 500 watt hour per kg of the cell at the cell level. And at the system level, that particular cell is going to give at least 430 watt hour per kg, and they have already started producing it. So that means we are talking something around this, which is right now only being considered in the solid state, and this is something which is already being produced there. So in terms of the first one, the watt hour per kg, which is the gravimetric energy density, we are already reaching to the best of the performances. But when we talk about, if you see the second part, the recyclable value, when we have these type of the gravimetric energy density, the recyclability is almost poor to bad. There are manufacturing limitations we cannot increase as of now, but two good parts are coming here. One is the safety and the secondary is the high temperature operation. That means when our usability and our supply chain people are thinking about switching to something else, definitely we have to look something around this. This is the area where we have to look around, because these two are the manufacturing limitations, but here we have a lot of raw materials available, and this they are suffice for the long term viability also. If you see in terms of the cycle life, these two, that means the silicon one and the lithium sulfur one, are very much suitable for the ESS side. And if we talk about in terms of this also, the water per kg is less, but the cycle life is very high here also, which is the sodium ion. However, this 130 to 160 we are talking about right now at the cell level, but already around 180 has been achieved. So at system level, this will come around 120 watt hour per kg, which is okay for the vehicles to adopt. Now where the technological challenges comes in this entire supply chain, the first life of the battery goes into the EV if it has a higher performance. Of course, when it falls to the lower performance in terms of the gravimetric analysis, it goes to the ESS first and then directly for the recycling. There is no refurbishment life for this. However, between 75 to 80% for the grade 1 battery, it goes to directly to the technology, to the the higher technological line, which is the EV utilization, and then the second life. But the biggest problems comes here. This is the technological challenge in the entire supply chain. Entire Nobody knows when this is going to come. The forecasting of this particular knee, when this jerk is going to happen, is something which still people are finding it very very difficult, because the chemistries are changing. No two cells even of the same manufacturer are exactly same, and that is where I think a lot of attention has to be paid, because even in future when we talk about the very important part of the resale value, this is the place where the resale value will be impacted a lot. If we don't know what is going to happen of the when this point is going to arrive, how will you determine the resale value of a particular vehicle, especially when we are talking about 35 to 40% of the cost associated with the battery, overall battery, not only the cells. Now, when you reach to the second life as well as the recycling, this complex structure comes into play. But let us break it down very simple. This is incoming assessment. Here this is the retired battery system. Once it is rejected, it goes to the disassembly, wherein cables, electronic components, enclosures, cooling plates, fasteners, all are removed, and then we get the battery cells. And then it goes to the mechanical integrity inspection. If it is integral, then it goes to the second life processing, which is the refurbishing. If it is damaged, directly disposal. Then it goes to the direct measurement, aging mechanism, cycling, th- then all the safety evaluation parameters, which includes the testing as per IS 156 and 038 version 2. The tests like nail penetration, overcharge, overheat, crush test, all those the safety tests are being done. Approved, IS being applied. That means that is the place where the battery is being remanufactured from the cell, the refurbished battery. BMS is applied, and the second it goes into the second life. After which it has to go to the recycling. Uh, so when we talk about this particular area, when the integrity is managed, even this testing right now is very very tough. Most of the cells goes directly here. Even if it is being tested, going through all this cycle, getting it tested here, and then going up to the recycling is in itself is a big challenge for all you know the ESS people as well as the EV people, because cells are being welded with the laser welding now. Removing each and every cell in itself is a very very big pain point. Now, how to the navigate all this? There are certain solutions which are available at the utility perspective. Certain solutions are at the manufacturing side. So the battery swapping stations is one area wherein the not only the range anxiety will be addressed, but it also helps the consumer to have the leverage in terms of what type of subscription they want to use without having a lot of capex investment. Next important part is the collaborative R&D initiatives. This is the place wherein no one person want to take the risk, because you don't know the outcome right now of the unproven technology in itself. People has to come together wherein labs, OEMs, and the sellers, all three has to come together to put the efforts here, because everybody understands one or two pain points in their area. In terms of the incentivizing domestic manufacturing, yes, PLI is there, but the entire value chain is not yet covered. And I think, of course, now we have to wait at least for 3 to 4 months minimum to see any developments in this area. But I think this is the time wherein a lot of support can be built in, because people will be, answerable during this point what they can do once they come into the power. And this is the place wherein a lot of commitments can be sought right in the beginning itself. I think industry associations, others can do a lot of good work in this area, and during these 4 months in particular. Next is the skill development programs. In fact, all the companies, OEMs, they will put their hands up that yeah, this is a big issue right now. Finding out the right talent at the right price in itself is a big challenge, and then retaining that talent, this has become a the nightmare for most of the companies. So of course, collaborative R&D, incentivizing local production, skill development, and regulatory framework enhancement, these are the tools which has to be deployed. Otherwise we are going to lag far behind with the prices going down of the raw materials, and there is a competition which is being built up. We have already seen a lot of companies dying in the last 6 months, and with the the type of incentive which has come up for the next 4 to 5 months, the 500 CR, I think to get the revalidation certificate and all, to get this money, the 500 in itself is going to be a nightmare for most of the people, because you have to get the revalidation done for your vehicle. I'm talking about the MHI's declaration which has come up a day before. That's it from my side. Thank you very much.
Thank you so much for that insightful presentation. I'm sure there was so much in the presentation to take away. It is now time for us to get on with our panel discussion session on forging links in India's EV battery supply and technology chain. And for this, today we have with us a set of our esteemed panel. Mr. Gaurav Dolwani, who's the CEO at Lico Materials, Mr. Gautam from Race Energy, Mr. Nikhil Khurana from Fox Motor, Mr. Shashikant from Australian Power Systems, and Mr. Prateek Singh from Nomura Research Institute, who will be the moderator for the session and lead the discussion. I welcome all of you today on the screen, and now handing over to Mr. Pratish.
Thank you very much, Sakshi, for introducing the panel and bringing all of us together. Let me give my regards to Randhir Singh ji for a very insightful presentation. And during the presentation also, he has brought a lot of issues, a lot of things which we can debate and detail out during the presentation.
Thanks, Pritesh.
I'm glad nobody can be as good as Randhir ji, at least in the lithium ion segment. So he knows it all, and probably we need more time to discuss with him. So thank you very much, sir, again. In this panel, we are fortunate to have experts from the battery manufacturing, retrofitment, recycling, battery swapping. So all type of people are available. The experts are available to give their opinion around different subjects. I will be talking the issues and the challenges which we are facing currently as a country. So I would request all the panelists to be precise and to the point. Let me begin with the Shashikant ji, who is the VP Manufacturing, Australian Power System. Shashikant ji, if my understanding is correct, And I believe the Octalion has been very active in India's lithium-ion battery manufacturing with the pack assemblies and supplying to Tata Motors since long, especially in the buses segment. So this is there in the public domain. Now, I would like to ask your opinion about, how have you seen the entire lithium-ion battery manufacturing, dynamics changing in India? So, for example, uh, in the beginning, we used to talk about which battery is going to be the winner in India, for example, because that time global manufacturers were mostly focusing on NMC chemistry. So it was understood that for the high voltage systems, probably NMC chemistry is going to be the one of the major chemistry. But can you just talk about how the evolution has happened from the market side and which battery chemistry is really more prevalent nowadays, and going forward, how the battery technology is going to evolve in India? And also, please touch upon the India's focus on local value addition, local battery manufacturing. So both the things, how manufacturers are transforming and how the India's, the entire EV ecosystem, especially for the lithium-ion battery manufacturing, is changing.
Yeah, thanks, Pritesh. So definitely, yeah, we can discuss. We can address all the question. So starting from like the trend currently into the lithium-ion manufacturing, which chemistry to be used. So you said is correctly like very starting when the this era of EV has been started in India. The people are more into looking the NMC chemistry as one of the solution for making the lithium-ion battery packs. Again, I believe like NMC is the right solution when you have the restriction of the space, like where you have to store the more energy into the limited space. Okay, NMC is one of the like best solution. So that's why this NMC chemistry is very popular. You can see in the two-wheeler and the three-wheeler segment. But if you move from like the bigger segments like the commercial vehicle and the passenger vehicles, still I can say passenger vehicle is struggling between the NMC and LFP. But commercially, definitely the people will like to go with the LFP. Like there are two, three reasons. One of the reason is that again, the biggest driven factor between the chemistry NMC and LFP is the cost. That is the biggest driven factor. And if you see in terms of the availability, like the chemistry getting manufactured into the China, then again LFP plays like first role, first place. NMC is into the second. So that's why like before 2 years back, 1.5 years back, we were also using the NMC for even the chemistry for the CV business also. But the challenges what we have faced is that first of all, the cost of the NMC is high. That is first point. Second point, there are some certification tests which are like mandatory certification tests in terms of like AIS 038, AIS 048. Those tests are very mandatory, and in that whatever the tests are there, like in terms of the safety, those are very stringent. And if you see the NMC chemistries are like uh, uh, NMC chemistries are having the challenges to meet those requirement of the test. For example, nail penetration, which Randir has just now tell. Like you see the passing percentage of the nail penetration on the LFP is more than the NMC. Again, it's a volatile chemistry. So I can say the now the industry is shifting. So whatever the application right now running on the Indian road, I can see 80%, 90% are all with the LFP chemistry. There are very few. I'm talking about the passenger and commercial vehicle. Definitely,
Correct. Yes,
two-wheeler
understood.
business is two-wheeler, three-wheeler business is most of the NMC. So that shift also you can see, the segment-wise shift also you can see.
Yeah. So,
But yes,
Shashikant, this
yes,
brings to a uh, very important question. So you mentioned two things which are very important for country, also for all the ecosystem players, also even consumers. For example, safety is very important.
right.
Safety is not only important for consumers but also for OEMs, battery manufacturers, because if something goes haywire, then it can have a very large impact on your brand also. So safety is important. Cost is also very important.
Correct.
Now, because of these two things, uh, in India, things are moving from NMC to LFP and probably LMFP in future. As you said, that two-wheeler, three-wheeler might be there with NMC for us for at least some period of time. But in passenger, it can be like 50-50. But in commercial vehicle, it's going to be around, let's say, more than 80%, which is going to be on
Yeah.
electric.
Right.
Now, let's say this becomes a reality. In down the five years, it becomes the reality. Then it brings actually more and more challenges only, which Randhir was also talking about in his presentation, that it's going to kind of bring a lot of challenges for recyclers. It's going to bring a lot of challenges, in terms of other battery chemistries. So don't you think how then it is going to make because there is no resale value, there is limited technology available for recycling, then the reuse and recycling becomes a very, very big challenge. So how do you think things are moving in that direction? On this question, I will take opinion from Gauravji. Before that, I want to discuss one point with you about the cost or the battery prices. So in last 1.5 year or 1 year, if you look at the battery price evolution in India, it has gone in Indian conditions. In Indian conditions, I'm talking because we have limited volume, so the pricing might be higher what the pricing is there globally. So now it's like $70-$80 at cell level, maybe for grade A or grade B cell. Maybe you can correct me. And then, do you think now it's stabilized, or again it's going to be there is a sudden rise or sudden decline going forward also? Why am I asking this question is that because it then doesn't makes business case feasible for reuse, recycling if such kind of sudden changes are happening. So on pricing point, Shashikanji, your question.
Yeah.
Then I'll go to Gauravji. Yes.
So yes, it's true that in recent few months, I can say probably in one year time span, the prices has been decreased rapidly, but it will get stabilized. Again, it will not rise so much. Like Randhir is already explained, there are excess metal availability into the China. The raw material is excessively available, and that's why the more batteries has been more cells has been getting prepared in China. That's why the price has got reduced. But I think it will stabilize somewhere. You likely said $70-$80 per kilowatt hour is currently the trend is going on, and then definitely it will get settled. It will get settled very soon.
Right.
And in terms of recycling, again, like Gaurav is the right person who can comment on this. But I think we need to thought of like second life also. So there are like a lot many applications where India is currently not thinking of. But if you go to the Europe or the US, like more energy storage systems are there, ESS systems are there where the demand is more. So maybe once the whatever the life is there, which is getting exhausted for the automotive application, then there are a lot more other applications, lot more market is available where we can still use that battery for its second life. And once
especially in stationary applications, there are a lot of usage of such batteries. Shashikanji, one more question to you, which is regarding the because most of the cells are coming from China. So let's assume that the battery manufacturers or the OEMs across the vehicle segment, starting from two-wheeler to three-wheeler to passenger cars and commercial vehicle, do you think they can really depend on keep sourcing from China for a longer period of time, or they need to also have a strategy to change the cell suppliers once they develop in India, and what can be the timeline for that? Because it's a very, very strategic thing which we need to decide, because it will impact the cost, the supply security, and other things. So do you think this cells coming from China is going to continue for another decade or so, or and there is no challenge in terms of sourcing from China, because there can be restrictions of sourcing cells from China? So do you think this trend is going to continue, or do you also think Indian lithium-ion battery manufacturing picking up and really able to supply passenger cars and commercial vehicles also?
So I can think like, again, Octulion is like a cell agnostic company. Octulion does not make their own cell. So we depend upon, like, we are expert into the battery packaging. So as per the customer requirement, we choose the different cell manufacturer in China, and we give them the solution like which cell is suitable to them. But yes, we need to find out our own ways to develop the cell in India. That is very, very important. That is the need of time, because our now market is now growing, the demand is now growing. Now it's the time we should we should be independent of the outside China agencies, outside India agencies to import the cell. And with respect to that, the government has given a lot of schemes. For example, the PLI is one of that, where they are helping or boosting the Indian cell manufacturer to come up and set up the
got
cell
it.
manufacturing facilities. And that
Thank you.
the efforts has been started. Already efforts has been started. But I think the only challenge what I can see is that even though we made a cell, the validation, testing, related facilities needs to be available in India. That is point number one. Point number two, the field data. Once we made the cell, validated the cell, and that cell is running on the Indian road, and we are getting the feedback, and same kind of corrections are happening on those technologies, on those chemistries, on those formulas, and then again it is getting revalidation. So it's again cell making in India and starting the commercial use of the cell is again like making a vaccine.
Correct.
There has to have some trial 1, trial 2. The
You're
field
right,
data
you're
needs
right.
to come up, and then
Correct.
those things need to be modified, and then it need to be going into the field. So it will take a time, but we
Yeah,
are on the
sure,
right
sure.
direction. We are on the right
Correct.
direction, and definitely we will be there one day.
Yeah, I mean, really, amazing input, Shashikantji. Now moving to Mr. Gaurav. Gaurav, Shashi talks about PLI scheme, which probably is going to enable India to have its own battery manufacturing. He also talked about being cell agnostics and depending on China. He also talked about, if he's kind of very agile in terms of cells also, right? Whether it is LFP, NMC, depending upon market situation, probably they can change it. But the more and more changes battery manufacturers are going to do, or the OEMs are going to do, it brings more and more challenges for a recycling company, right? So my question number one, even if we are having domestic battery manufacturing, if you look at the announcements, they are mostly going to tap two-wheeler and three-wheeler. So for passenger cars and commercial vehicles, cells are going to come from outside. So two questions I have for you. All these changes are happening, then how you as a recycling company or as a recycling industry need to be ready all the time, and whether such kind of flexibility is available in the technology changing or not, number one, which is I think applicable for future. Second, what kind of recycling is currently happening in India? Is it at the level of black mass only, or we are extracting the materials, the critical materials? If we are extracting the critical materials, whether we are getting the right pricing in the market. So I want you to talk about these things.
Thank you very much, Pritesh, and thank you, eMobility Plus, for having me on the panel. I appreciate it. For your first question about what kind of agility we should have as recyclers, given that chemistries are changing frequently. So, as a company, Lyco today, we are able to recycle any different kind of chemistry. So we're chemistry agnostic. We can recycle NMC, LFP, LCO, LMO, LTO, etc. Of course, it's important to consider that these chemistries cannot be, most of them cannot be mixed with one another due to avoid cross-contamination. So the challenge would be where's the volume in raw material? Today, volume is in personal devices such as mobile phones, laptops, etc., which is considered LCO chemistry. We are seeing some NMC chemistry coming our way from OEMs. LFP is still slow. And then, of course, there are very few OEMs who are working with LTO or LMO, which is a very niche kind of technology. Now, as a country, where are we in the recycling industry? Still very nascent stages. I think we are quite a way behind our contemporaries in Asia. I think China, South Korea, etc., Japan are considerably ahead of us. The reason is that those countries have promoted recycling. They have been incentivized for recycling, which currently as a recycler we are asking for, because currently we don't have those incentives. At the same time, I think that recycling is something that has to move step by step. So the first step is the mechanical separation to come to something called black mass, which is essentially a combination of anode and cathode. And then the next step would be recovery of metal grade salts or metal form from black mass, which could be done via hydrometallurgy, pyrometallurgy, or direct recycling. There are a few options. Hydrometallurgy seems to be the preferred choice for most. However, we are at a very, very young stage in India at hydrometallurgy. We are still talking about lab level. We are still talking about very small quantum of salts. When we want to talk about battery grade purity so that it goes back into the battery ecosystem, it has to be done at large volumes at a very high grade purity. My personal belief is that we are, as a country, a long way away from that. Now, do we get the commercial value? No, because commercial values typically are done when volumes are involved. Currently, we don't see any large volume player in India who is signing any kind of deals of mineral salts with any of the PCAM or CAM manufacturers.
I got it. So I think this brings. Let me just talk about how any technology or any even in the electrification things are happening. So around 2010, people got excited about electric mobility in India, and then policies are coming. Policies have come for battery manufacturing, for vehicle manufacturing, for charging infrastructure. There is a policy for recycling also, but that is more in terms of restrictive and making recycling industry capable. And if you look at every policy, for example, FAME was initially designed for 2 years, and now it went on like for many years. We can fairly assume that it's a 10-year policy. Obviously, we need to be very agile and keep changing depending on the market situation. Charging infrastructure, again, a decade policy, both from central government, state governments. Same is happening with the PLI for ACC, right? It's a 5-6 year long policy that too. I am sure government is going to be a little bit flexible in case companies are not meeting some timelines or deadlines or so to kind of support the entire. So there is a monetary support. There is also other kind of considerations. At the same time, we define the materials as critical material, which is going to come from the recycling. But I personally do not see that kind of policy support for recycling. So do you think there can be a separate PLI, or there should be a separate PLI? Otherwise, until or unless there is a big volume, it's not sustainable, it's not making economic sense. Do you really need a long-term policy that too with incentives to make lithium, so to make recycling industry sustainable? Because whatever we are claiming as critical has to be considered as critical, and a lot of focus should be there.
Absolutely. I mean, I think the government has done very well by introducing a PLI scheme for ACC. Of course, Randhir was a big part of that, who just gave us a great presentation. Now, the scheme or incentivization has to happen across the supply chain. So it has happened at cell level, but there is no incentivization for the anode or cathode manufacturer. There's no incentivization for the PCAM producer, and then the recycler. And that explains the gap why there are no anode, hardly any anode or cathode or PCAM manufacturers or any plants being even announced in India. These are high capex plants with large risks in a evolving technology sector. Without any kind of incentivization or government support, it's difficult for companies to commit to that kind of capex without knowing, who's going to be there to buy these at the end of the day. Where's the offtake? So recyclers are at the bottom of the chain. So I think still number 2, 3, 4 all need to be incentivized. Now, in terms, if incentives take time and if policies take time, which they normally do, and that's completely fine. In the meanwhile, if India considers that this that we are talking about these minerals as critical minerals, then we should be allowed to import these critical minerals from abroad. And we cannot say that they're critical minerals on one hand and then treat them like waste with the other hand. So if there are critical minerals, allow recyclers to import them, allow them to do R&D, allow them to understand, so that when that time comes, that we get in a huge influx of raw material at that inflection point, we are prepared. Today, how many of us, I mean, we're maybe 10, 12, 20 recyclers, I would say, for lithium ion batteries in India, who may be formal. There could be a bunch of informal ones, but at least the formal ones. How much access of raw material do we have from OEMs? That figure is very small. And for each of us to go out there and commit to, again, huge capexes to set up hydrometallurgy plants without even having an idea of what kind of raw material we're going to get is always going to be a chicken and egg story.
Yeah, Gaurav, I think we always talk about, three major issues around electrification or the national objectives: energy security, manufacturing import dependence, and the emissions. Even if the energy security part, if we look at, so we always say that either we need to have our own resources, which we are trying through mining, and different explorations are happening in different stages. The identified reserves in J&K and other parts of India. At the same time, I think we also talk about that whatever we import should not go out of the country. We should effectively recycle and then reuse, and feed into the system to make the loop close. But I think your point of view is very right, that whatever we are, because it's a critical material, then probably there has to be some mechanism or limited hurdles to import the raw material. Now moving on to Nikhil. Nikhil represents the retrofitment, which is, again, we can consider him as a OEM. So let's take the point of view or the opinion from an OEM, and that too it's going to be very, very different, because the retrofitment OEMs are a little bit of different from the real OEMs, because a passenger car company or a two-wheeler or a three-wheeler or a commercial vehicle has to give only 5% GST if they are selling the vehicles. But Nikhil, being a retrofitment company, has to give like 28% for passenger cars. I'm talking about less than 4-meter cars. Two-wheelers 18%, three-wheelers again, tractors again 12%. So depending on the normal ICE vehicle, the GST rates are same as what are there for the normal vehicle. At the same time, the batteries, the motors, inverters, controllers, all critical components are very same, and he gets at the same prices. So one is this taxation part. At the same time, there is no applicability in FAME 2, at least, and also in the new policy about retrofitment. So again, there is no benefit. There's no benefit in terms of GST. So it probably makes very, very difficult doing this retrofitment business. So what it leaves it, you are just converting two-wheelers where it makes a little bit of more sense. But when you move to passenger vehicle, converting them, or the commercial vehicle, it may not make economic sense. So Nikhil, what's your opinion around that, and what are the possible solutions, and what, as a recycling as a retrofitment fraternity, you request from government or other stakeholders to consider?
Well, thanks for the opportunity for speaking at this webinar session. And somehow we all believe that retrofitment as a product category and as a market segment is somewhat like a black sheep in this entire sector. And but it plays a critical role in evolving the electrification for India as a market, and even globally. It's a huge opportunity where we can, tap into the emerging technology, which is still at a very nascent stage. Entirely the ESA is very at a nascent stage, and somewhat retrofitment can play a pivotal role for the entire supply chain consolidation and the demand aggregation for systems and components, typically like EV battery systems and electromechanical components, like say like powertrain platforms and electronic control units, which can have proprietary applications to believe, and it can create huge IP for the evolve for the evolution somewhere in this entire EV ecosystem. And how we have been trying to do the past 7-8 years of our existence in this market, and even 10 years, 10 to 12, 15 years before now. I mean, we started with inventing technology platforms on for powertrain systems, eventually for electronic uh, calibrations, as in to develop XEV powertrain platforms, which can moreover add value to an existing vehicle like a passenger car. And eventually, I mean, with our technology expertise in this domain, people have came up to us that, okay, can you help us design and develop systems for electric tractor applications or truck applications, or and even from the aftermarket space, we have been hearing everyone about how we can get the spares and services, because the vehicle manufacturer, which we call it as our big brother uh, in the industry sphere, but somehow we play uh, a parallel aftermarket role for that existence of this value chain as well, because certain dealers uh, which don't get support enough from OEM manufacturers, the vehicle manufacturers, to get spares and services uh, to adapt to the ever evolving need for the customers. And somehow we play a pivotal role for procurement and distribution in those for that EV systems and components. Uh, and we just try our best to to play and add value to this entire supply chain cycle, which is where we, I mean, somehow lacking the resources, part of where India lies,
Correct.
about not having enough rare earth materials, and also in the demand aggregation side, where there's still a very lag between how vehicle manufacturers have been able to build their channel networks, and how they have not been able to do enough for the aftermarket space. So somehow the retrofitment product category and a market segment would create enough bandwidth for the entire ecosystem.
Yeah, and I think Nikhil,
Where
that
we are.
brings to a very question of having a separate HSN code also for the retrofitment. And if my understanding is correct, I think we don't have any HSN code separately, and till the time it's not there, it's very difficult to under the framework, entire framework, to give special benefits, GST cuts, and on any kind of incentives on. So is there any effort being made on that, and what do you see emerging out of it?
See, somehow this product category needs a comprehensive GST framework, because as in our auto industry, every component from the smallest to the smallest unit for a system has its own taxation framework and GST applicable depending upon its application. Somehow every vehicle segment has its own framework, but this product category, which is a XEV retrofitment, still lacks the comprehensive GST framework for it, and we are not been able to source the right components at the right price and
Hmm.
costings
Hmm.
to cater to the customer right cost and price there as well. Because I mean, somehow it's a lack from the government side provide us the
Right.
best of the best in the policy framework. So we are open to uh, accept a lot of help from all lot of
Yes,
people
yes.
in this industry.
Yes, I think stakeholders here are also, I mean, very important for a retrofitment company. So, thank you very much, Nikhil, for your opinion on this. I think very, very important. Now, moving to Gautam. Gautam, apologies, I kept you waiting. I wanted to hear out from all the other, representatives, because it's like your company is user of the batteries, and also eventually, because you use the batteries, and now you are the owner of the batteries, then you are really going to worry a lot about the reusing of the batteries or recycling of the batteries. And in this perspective, I think safety for a swapping company becomes very, very important, because these batteries are being used in different vehicles. Obviously, they those are the vehicles which are tested and validated even from a swapping company. But what are the challenges around safety of a swapping station? Because one is like location placing, second is about the safety of the swap station, then safety of the vehicle with your batteries, how you are ensuring that, number one. Second is, once demand goes very high for a swapping station, because you are placing a large number of swapping stations, and some of them are also very close. So how are you kind of managing the demand? Is there any mechanism from which you can switch, or you can direct one consumer from a high utilized swapping station to lower utilized swapping stations? Number two. And third question, what's your opinion about entire localization of the batteries in India, whether your batteries are locally produced, packs you're taking from India, or how do you plan to utilize domestically manufactured batteries? Whether there is a scope of domestically manufactured batteries in swapping or not. Three questions.
Yeah, thank you so much, Pritesh. Three very different and exhaustive questions covering the swapping model itself. And yeah, starting with the first scenario of battery swapping as a model itself, right? So, uh, in essence, it's a very new technology when you talk about the Indian EV ecosystem in general, because everybody has been noticing fixed battery vehicles which come along with the battery to the market, and they're very used to buying and using them on roads. So when it comes to battery swapping, in fact, it comes with added safety and removes the concern of managing or charging the battery from the end user, because we as battery service providers, we are more concerned about the battery usage, how we are going to charge them in the battery swap stations, the life cycle management of the batteries, and the safety of the batteries when they come to us. So the end user is only concerned with coming to our stations, replacing the batteries, swapping them within a couple of minutes, and going back on road. So that's the added advantage that battery swapping as a business model brings into picture. When you talk about safety, because the batteries are being controlled by us and charged in controlled environments inside the battery swap station, we in fact ensure added safety while charging the batteries. While charging the batteries is when a lot of different things could go wrong when compared to discharging. And because we own the batteries, and we take care of the charging profiles, the temperatures of the batteries when they're charging. Before swapping them out, we even have complete checks of all the parameters of the battery, if they're all within the safe threshold limit, before giving out to the customer, right? So all these safety points get added, and what goes to the customer at the end of the day, or the end user, is the best battery packs, the very safe checked battery packs that comes to them. On top of that, when you talk about advancements inside the battery, we've been talking about advancements in cell chemistry, advancements in thermal management, software layers that go on. So the end user doesn't have to keep worrying about, are my batteries getting outdated? Do I have to go to the showroom to get it updated with the software and the technology that's coming? Because battery swapping takes care of that. As the industry evolves, the end user is only concerned with the vehicle, and he can be rest assured the best battery technology that's available is what is running in his vehicle at any point of time. So
And
that's what comes into picture with battery swapping.
And Gautam, which battery chemistry is more prevalent? Because we discussed about vehicle segments, different vehicle segments, and the type of batteries. So in swapping, whether it is an NMC or LFP, because it goes mostly into two-wheelers and three-wheelers, and space is definitely a constraint.
Yeah, so I think Mr. Shashikant broadly described it perfectly. So there is a mix of both LFP and NMC. We at Race Energy, for example, use NMC. We cater to two-wheelers and three-wheelers in our battery swapping service, mainly to do with the space availability and the weight of the batteries that go inside the vehicles, right? So there are swapping companies which also use LFP, to cater to bigger vehicles, cargo vehicles and four-wheelers and so on and so forth, where the space and energy density constraints is not there. So there is a mix of both, like already discussed and touched upon in the previous
Yeah.
by previous panelists. There is a mix of LFP and NMC, more towards NMC because battery swapping mostly caters to two-wheelers and three-wheelers at this point in
Yes.
time.
Yeah. Thank you very much. So, Nikhil, your perspective around this topic again about the sourcing of battery manufacturing, sourcing of batteries for retrofitted solutions. What is the current status there, and what changes do you foresee in future for the retrofitted solutions, which includes batteries?
See, somehow, I mean, there's uh, entire value chain as well as the supply chain needs to get aligned together, because see, uh, when we source the right anode and the cathode materials for cell manufacturing at first, still India has to work a lot in that sphere, and somehow at the right pricing or for the right chemistry composition, it needs right design, engineering, validation, even at the cell level for this sort of a market and environment conditions where our vehicles operate in. Somehow, I also believe that new sort of chemistry has to be explored, or even solid states, uh, and because a lot of OEMs are working on that sort of a technology platforms as well. And I believe India, where LFP chemistry is on its verge of
Correct.
existence, where in every
Yes.
single segment, and the entire from the right materials, then to right cell procurement, then to the entire pack design, taking to the value chain in terms of retrofitment, which can again play a huge role. Because somehow when there is for electric three-wheeler product categories, as per the government highlight that they need to have mandatory lithium-ion systems as their energy source. So a lot of existing vehicles in the three-wheeler
Yes.
segment
Yes.
need that adaptation, and
Mm.
retrofitment category can play a very pivotal role in that for aggregating sort
I
of
got it. Yes.
right.
Thank you very much, Nikhil. Now, I will take up a last question, and I will start taking the opinion from Gaurav or Shashikant on this, and then other panel members can also contribute on this. So, Gaurav, if you have, I'm sure you have seen that the technology is very important in terms of the batteries. So, if you look at the component industry, how it has evolved in India, uh, you know, other than technology, we give everything. So, from outside, we bring the technology all the time. We invest and we provide connections of the OEMs, sales support, marketing support, all kind of support we provide. R&D resources also we provide, but we really don't have the critical technologies even in the existing automotive industry. Now, in the batteries, the R&D is happening all outside India. In R&D is happening in India, but innovations have happened mostly outside India,
Right.
including China. So now, in that innovation, obviously OEMs, battery manufacturers, industry players have played pivotal role, but government has also invested either through the educational institutions or by themselves, promoting these stakeholders to have R&D in place and do innovations. If I recall my discussions and visits and talking to educational institutions, including top-notch educational institutions in India, I find two types of institutions. One, who can possibly innovate, and they are trying to, including IITs, etc. And second layer, tier 2 and tier 3 engineering institutions in India can feed the entire system with the trained resources. They are also realizing this and they are making an effort. So do you think now is the time when we really have to focus a lot on R&D so that we have the technology and we own the technology and we try to have some ownership on the game? Otherwise, if we keep depending on the technology is not going to be available with money, I believe. So what's your opinion, Gauravji, on that? And then Sasikanji, and then it's open for other panelists.
Yeah, for the security of our own country, it makes complete sense to have our own technology. In order to develop our own technology, we need government participation, we need industry participation, and we need academia participation. Now, in our country, this has not been something that we have been doing for years. If we see Europe or if we see the East, academia and industry go hand in hand. Unfortunately, that has not been the case in India, because we feel that it's an easier solution to get commercially proven technology from abroad and put it here. So there's lacking on both sides. I think that is required, that effort needs to be done from both sides. But yes, in the long term security of the country, I agree that technology should be in-house.
Shasikanji, your opinion on that?
Yeah, I agree. Agree with what Gaurav is saying. So again, in terms of R&D and technology, definitely currently whatever the few people are making the cell, definitely they are exploring the new things into the cell manufacturing. But again, like for us, the battery pack manufacturer, we are expert into the packaging of things. I can say still there are lot more opportunity to do the R&D other than the cell. Battery is not only the cell. I understand the value is more, the content is more, but okay, that will not give you the more energy density or more like safety. Not only the cell, there are rest other parameters also. Now I can say you if you see the bottom enclosure, like one of our pack, commercial vehicle pack, is having the bottom is made up of a low pressure die casting. And the battery pack is huge. The battery is 100 kWh, 100 kilowatt hours is the battery pack. That's why the bottom tray is almost 1.5 meter by 1.6 meter. Now, if you ask anybody in India, you wanted to make this part in casting, how you will do? Definitely the answer will be a sand casting or gravity die casting. But the sand casting and gravity die casting is not applicable for battery pack because the porosity will be there. Then I cannot meet the IP67 challenges. So we have to make that part in the low pressure die casting or high pressure die casting 100%. We don't have a choice to make in sand casting or GDC. Now, if you see in India, nobody is having such a big machine where you can accommodate 1.5 meter by 1.6 meter part into the bed. Everybody is having the small. Nobody has explored the option of making such a big part into the high pressure low pressure die casting. The battery industry is the first one who wanted the bottom enclosures to be made into the pressure die casting. Such a big, I'm saying, not small, the big bottom enclosures. Again, since we are making the bottom enclosure in die casting, again, you will see if you make that part into sheet metal, we will make with 4 mm, 5 mm thickness. So similar way, I have to make that part into 4 mm, 5 mm thickness. I will challenge you. I have met all the big alloy guys in India. Nobody is confident to make the die casting part in 4 mm. So there are lot more opportunities to do the R&D other than the cell.
Yeah, that's really an amazing point of view. Reaching up to cell level is obviously very, very important, but there are so many other things also where innovation can happen. Thank you very much for your opinion on that, Shasikanji and Gauravji. Gautam and Nikhil, do you want to give your perspectives also on this?
Yeah, I'll just add a few pointers to what Shashikant had mentioned. So it's not just the cell, like he rightly touched upon. It's a lot more to do with the mechanical aspects, like he talked, and also the electronic components and the microcontroller units that we use, the ICs and chips that we are heavily reliant on other countries in countries from Southeast Asia right now, right? So even if we say we make the cells in India, we'll pack the battery in India, we are still dependent on these components that fill up the PCB boards for the BMS, for the control systems, for thermal management. All of these still come from outside. There are 7 to 8 different industries which can contribute into battery manufacturing as such. It consists of the mechanical parts, like Mr. Sashikant mentioned, the electronics that I'm talking about, the pecan industries, the electrolyte industry that's needed for the cells. So 7, 8 different industries have to come up in tandem to make sure we are fully self-reliant in making cells and battery packs. So the PLI schemes obviously have started off on a very good note on the cell side of things. And if the government can go ahead, look into the other different aspects that can benefit from schemes or policies that come into picture, and introduce the entire ecosystem in India that can add into battery and EV production as a whole, that is when we will fully be confident of saying, we are completely making stuff in India. So that's my point of view.
Thanks, Gautam. Nikhil, your concluding remarks on this, then we will open up for the questions.
See, there's a demand for an existence of a centralized aggregator who would try to add and create value in the supply chain from scratch, from the rare earth material exploration, then to cell design and manufacturing, then to a pack design and manufacturing, right? There is a way to operate where certain companies cannot be relied on PLI only, because in PLI there's a minimum investment where you need to add up into a capex and also an order book, as in what you get a PLI for any auto component manufacturing as well. Okay, I mean, just how, or in auto component manufacturing, somehow the minimum capex is somewhere around 500 CR, and you need to get a order book on that as well to claim that, right? So somehow, so like even our company, we are looking for adding up financial services and the asset management structures to put in into the supply chain and value chain. And some of the emerging companies who are very small teams working out of academia or some startup teams needs to have the right financial bandwidth and the technology bandwidth to discover new and emerging materials, compositions for chemistries, and I mean, we are very particularly looking at them, where we can add up certain IP, certain part of our own IP, also help them to create their IP as well, and somehow collaborate on that to create the entire consolidation in the supply chain. And trust me, we have been uh, relentlessly working on this area in the past 2 3 years, and I mean 2020 onwards, we built our business to a good enough scale in the procurement distributions for battery systems, for powertrain platforms, for electronic control units, and somehow now we are trying to add up more of our financial bandwidth as well
Great.
in creating from tier 3 to tier 2 to tier 1, giving them the right technology expertise with design and engineering validation and the capabilities to it, also the financial bandwidth in the capex and the opex. So we're trying our best to add up into
Thank,
this segment as well.
thank you, Nikhil. Thank you
Thank
very
you.
much for your opinion on this. Uh, with this, we come to the end of this session. I think it was really amazing discussion covering from the variety of opinions on variety of topics, and I thank eMobility Plus to organize this and give us the opportunity. Over to you, Sakshi, in case you want to open up it for questions.
Thank you so much, Mr. Pritish, for the way you totally amalgamated the various interests of the industry and related those interests to the panel of experts and made this discussion definitely very constructive. It is now time for our Q&A session. So we have received some great questions from the audience. Let's dive in. I shall be screening these questions, and Mr. Pritish can delegate these questions to whomever he thinks deems fit to answer.
Yes,
them.
please. Can someone from the panel answer my novel question as to why can't we manufacture battery cells in India rather than just packing Chinese cells into the Indian boxes and putting? Yeah, I think just saying that we are putting Chinese cells into Indian boxes is not, yeah, it's correct, but not 100% correct. As the panel members talked about different innovations happening and possibility of different innovations happening other than cells is also important. And I think all the debate is all happening around this question of localizing the cells. So I'll ask Shashikant and Gaurav to give their opinion on this in case any one of you.
Yeah, actually, I answer to the test box here. Again, we are not like a cell manufacturer. Like I again said, it's a different kind of like industry. For us, it's we are the battery pack manufacturer, battery packaging expert, not the cell manufacturing. But like I mentioned into my chat box also that there are efforts are going on to make the cells. But again, the challenges are like once we make the cell, like to test that cell, validate that cell to the different scenarios, different temperatures, different driving habits. All those things need to be tested, and the cells need to be validated. And most important thing is we need to have the field data to make the correction into the production batches, which is quite possible for other things, the mechanical things. Okay, something goes wrong in the field, we got the communication, and immediately we have done the corrective action in the production line, and the next production has been taken care. So such a kind of activities need to happen. We need to have the field data, and based on that, we need to produce the clear and clean the production batch. That is the challenge I am seeing. Rest, like the efforts are going on, and the government is fully supportive for that, and we have the potential market to make the sales in India.
Yeah. Thank you very much, Shashikantji. In addition to what Shashikantji mentioned, I also would like to mention 2 points. One is tech is not available and nobody is ready to give the tech, number one. Second is India as a country is not very, so 2 things you require, either proximity to the resources or a large commitment in terms of the numbers that this much we are going to electrify. So India has not come up with any definite target. Definitely, we talk about 30% electrification, but we lack in terms of proximity of resources, commitment, and also commitment in terms of the numbers. So these are also 2 important things. But I think things are already on through PLI. Definitely, we are going to have 2-3 manufacturing facilities in India. So actually, we can take another question. How to overcome the thermal challenges in EV industry? Again, Gauravji and Shashikantji, if you want to take this question, or Gautam.
Yeah, I can add in a few points. So when you talk about thermal challenges, right, it's not specific to any particular chemistry. So first of all, clearing that out, because when we say LFP is a safer chemistry or NMC is a, has some safety concerns, or LTO has other issues. So it's all about the use case specific, cells, what we're talking about. So LFP is very stable, of course, under a wide variety of temperatures that exist in India. When you work with different battery chemistries for different use cases, 3-wheelers, 2-wheelers, buses and trucks, and etc. So you need to design the thermal management systems accordingly. So the BMS that goes inside the battery is a very critical part that manages the entire battery pack. Electrically, parameters are being checked by the BMS. Thermally also, where it gets temperature readings from the sensors that run all over the battery pack. It reads them, set temperatures thresholds are defined for each battery pack and each use case, and the AIS 156 standards that have come out have mandated very strict, stringent testing for these smart BMSs that go into the batteries, which can thermally also manage the battery packs. So BMS is electronically controlling the performance of the battery under the different thermal operations and conditions. On top of that, there have also been stringent standards that have come into picture to prevent any kind of thermal runaway issues or thermal runaway situations within the battery pack. So now there are specific tests separately, targeted at infusing thermal runaway conditions inside the battery and making sure the battery pack as a whole is still safe, even if 1 or 2 cells out of the hundreds of thousands of cells inside the battery go wrong. So there are tests specifically now designed under the new safety regulations that every battery manufacturer has to pass at this point of time. So thermal management electronically from the BMS and also adhering to thermal management systems that are built inside the battery pack.
Yeah, I hope, Colonel, I hope you got your answer. Do we have any more questions, Sakshi? This question is to Nikhil. So, Nikhil, can you talk about this? Can you suggest a suitable battery for a manufacturer of TV kits for 4-wheelers?
See, the retrofitment for 4-wheelers, every platform has its own operability, and thus, we can design the entire battery pack and its packaging along with its management system that must be having certain proprietary element in it, because every platform has a very different sort of operability as per our driving conditions. I mean, if tomorrow design some sort of parallel hybrid sort of a configuration for any vehicle, or a series hybrid sort of a configuration, it would require a separate design its battery pack. Somehow, what we have been building for the past 5-7 years, always been focusing on a generic solution, with the XEV solution. Series hybrid, parallel hybrid, plug-in hybrid, as well as a battery electric vehicle. So it's a generic solution. So somehow, even when we've been working on this, on the proprietary design of the battery pack, it has as well as its own solutions to be figured out in the entire pack level.
Yeah,
and the system level, where again it should have.
Yeah, thank you, Nikhil. I think Mr. Agarwal, there was some, unclarity in voice. So in case you haven't got the answer, you can directly connect with Nikhil. He's a very accessible guy and will talk to you about this. Sakshi, do we have any more question? Else we can close the session. Over to you.
I think we can conclude this. Does anyone have any closing remarks?
So it was really nice that eMobility Plus has organized this webinar and gave the opportunity to all of us, and it was really insightful discussion, and I thank you all the panelists on this. In case anyone else has some concluding remarks. Yes, Gaurav.
Thank you very much. Thank you very much for having us.
Thank you very much, Sakshi. I think we can close.
Yeah, thank you, Pritesh. Thank you, Sakshi.
Thank you, Gaurav.
Thank you all.
Thank you,
Shashikant.
Thank you, Gautam.
For your questions, audience. And with this, we have come to the end of this webinar. Again, a big shout out to our attendees for extending their time and support for the event. A special thanks to our esteemed speakers for extending their valuable time to help make this event a success. We promise to be back with another exciting session, and also don't forget to join us for the EV Manufacturing Show 2024 on the 24th of May in Bengaluru, and stay ahead in the world of electric mobility. The floor is now open for networking. Thank you, everyone.
Bye.
Yeah, thank you.